Thank you. Thank you, Irene, and Nina as well, because I learned a lot about pyrolysis, and I'm happy, Irene, that you started off on plastics, because I thought I was going to be the only one that was going to talk a little bit about plastics, because that's where I actually come from. I represent a company, a startup company actually, Upact, the Unwaste company, as we call it. Upact is an Australian-Dutch joint venture. We use an Australian technology to recycle actually all plastic waste, unsorted, unwashed, and unshredded. So that's an interesting one, but it's mechanical recycling. And we focus very much about what many people call the unrecyclable plastics. So the plastics that are very difficult to sort or expensive to sort, which we have a process for to do that. We have a test and demonstration facility built up in the Eemshaven. And actually, the location is at the red arrow, and that's actually also the reason I think that we're actually here, because you see already next door we have quite a lot of materials which resemble pillars and blades and stuff, and this area is currently being built to store decommissioned wind turbine blades. And there's a couple of companies in Eemshaven in Groningen that are actively working on solutions for those wind turbine blades. And because we are located there and we are in the midst of them, they asked us at a certain moment as well, can you use material, shredded material or fibers or other material from wind turbine blades in your process? And I said, well, I can maybe think about something. But that's what I will tell later. We now have a test and demo factory, and the plan is to start building, just behind this building, a full-scale factory with 4 production lines with a total capacity of 10 to 15 kilotons per year, input and output of plastic and textile waste. This is actually what our unique selling point is. It's a mixer melter of the different types of plastics, which we call the unwaster. With the use of pressure and friction, we actually warm up the plastics. And when the plastics are being warmed up, they become a little bit softer. And if they reach a certain plasticity, they are actually pressed through some holes in a turning rotor. And before they actually go through, because of this turning motion, the plastics will all be mixed very well. And normally when you try to heat or warm up plastics and melt them together with different types of plastic, that's actually very difficult, because they have different melting temperatures. One plastic is burning, the other one is not melted yet. And what you then try to do, if you melt them and you put them in a mold, is trying to stick together different types of plastics. And different types of plastics, they don't mix well together. They separate easily if they're warmed up again. So if you produce, for example, a construction material like a plank or a pole, you get weak points, you get things that separate, and that's often seen as low quality. In our process, we get actually quite a consistent and homogeneous material out of this process, which we can then run through an extruder, press into a mold, and you have a relatively high quality plank or pole. And that's a little bit the secret. It uses relatively low energy as well, because we don't even melt the plastics, and the friction that is used to heat up the material is a very efficient way of melting the plastics. And in the whole process, from putting in the waste and getting a plank out, we only melt the plastic once. In a normal process, you're compounding, agglomerating, and melting, so you're often melting the plastics 3 times before you have a plank or pole. So this is relatively a low energy process. What are we doing in Groningen? We are focusing on testing 3 waste streams. Maritime waste, it comes from ships, comes from the port areas, comes from fishing nets, for example, so from the other fishing ports. in the region, but also beach cleanups, and I put it in for this presentation, recycled wind turbine blades, maybe. We also used mixed plastic and textile waste, mixed plastic from household plastic waste, which is actually the residual waste from the sorting installations in the Netherlands, which are sorting all the different types of plastic. And they have around 40% mixed plastic waste, which they can't sort out more. And that's for us a very nice, material to work with. We are also setting up a collaboration with some hospitals in the Netherlands, the University Hospital in Groningen, because universities produce an awful lot of plastic waste, often mixed. We are not focusing yet on the medical textile waste, but we do the packaging waste, which comes every material or every equipment they use in the operation room is packed 3 times in plastic. So they have a huge amount of plastic waste as well, which in the Netherlands, most of it is being burned at the moment. And it's beautiful, clean plastic. So that's, for me, that's a waste. And light medical waste, we're setting up with the Amsterdam University hospitals. We're setting up a project, but that's in the starting phase because we first need to get approval from the ministry to handle that waste. What do we normally make from the plastic? Planks and poles is the most easy thing to predict. There's one designer in the Netherlands that has designed a climate tree. We can make that as well from plastic. We are focusing at the moment on beams and planks. And our test facility cannot handle production scale at the moment, so we are just making test molds. But we're doing quite a nice project for Seaports Groningen, where we're looking at the fenders in the port, which are along the quays, which used to be from tropical wood. And nowadays, of course, it's not seen as very sustainable to make them or to replace them by tropical wood again. So they've asked us whether we could make the beams from plastic waste, preferably plastic waste from the port area. So we source the waste in the port area, so from ships or out of the port area. We produce in the port, we produce those beams, and we put them in the port as well. And that's for us the first stage of a real circular concept, because we would like to bring back, as you were saying, with the wind turbine blades. If you use the wind turbine blades to make material to make new wind turbine blades, that's for us a fantastic viewpoint or option. So that's what we're looking at. And when we got a question from also through the port of Groningen and some of the people in Decom North, whether we could use wind turbine blades or whether we could recycle wind turbine blades, I was saying, well, I can't recycle wind turbine blades, but the shredded or milled material we could use. So fiber reinforced planks and poles are much stiffer, often much stronger, and we could make them as well. We're also working on a number of other climate adaptive products, as we call them. Walls, sandwich panels with insulation material in between to make the houses which are not very well insulated in the Netherlands. Add to that a wall which with insulation material could help them to become more energy efficient. And also there we're able to use some of the materials possibly from wind turbine blades, because glass fiber or Kevlar or other composite materials may have, in certain instances, quite a good insulation value. And that was another idea we had already to make those walls. If we can use the wind turbine blades or the recycled wind turbine blades material for that could also help. So those are actually 2 examples of products we are thinking of what we can use. Before we get there, there needs to be a lot of work still to be done, because we have to think about, okay, what's the composition of the material we get out of the wind turbine blades? I have no idea. You have a much better idea at the moment already what's in there, what comes out of that. We could also use, for example, you said the black fiber material you cannot use, but if it's carbon black, which is inside, we could use that very well in our material, because carbon black also acts as a UV protection for these products as well. So that could be also a possible solution. So I heard and I saw a lot of things today where I thought, like, well, maybe we can use some of the materials which come out of other processes as well. And that's also something which, as a company, we find very important, because we also have circularity in our DNA, as someone said earlier today. We are impact driven, and in a circular economy, you have to collaborate with all people in the value chain, also with other actors and other processes. Also, the play garden tools for or the play garden solution for the wind turbine blades, I think is a very nice one. Actually, I think, yes, here we have them. I promised already earlier today that I would say something about it. I know the people from Blade Made quite well. They were actually also invited to join today, but they said, well, I mean, if you can just include one slide, then we don't have to come all the way to Esbjerg, and we can do that as well. They make also noise screens out of the wind turbine blades, etc. And that's also, for me, a very nice solution. It's actually reuse, so it's one step higher in the hierarchy, the waste hierarchy, than actually recycling. So I like this one. I don't think it's a competition for us. If there is a need for these solutions, I would definitely like to promote them as well. So that's why I take them into my presentation. But I think in those sort of things we have to collaborate a lot. And Nina, thank you for explaining the pyrolysis process so much for me, because pyrolysis for me was always a little bit like, well, yeah, that's ultimately it's producing a lot of biofuel, what people call it, and that's burning, and the efficiency is not so good. But I saw today that it was actually a lot of developments are going on there, and if you can, with chemical recycling, go from molecule to molecule, that would be, of course, ideal. And I think also there we have to look at the whole picture and at all solutions, because solutions are needed urgently, and we can talk a lot, but it's good to see that so many things are already happening. And I hope that also with this group of people in Denmark, Germany, UK, Belgium, the Netherlands, if we work together, we can learn from each other, we can take best practices across borders, etc. We can speed up things, and I think that's very important. So I hope that I have given you some ideas. We would be very happy to continue with the ideas we have, and also that we cannot do on our own. We have to work together with other organizations, other companies. We have to find the financial means to do all the product developments and the material testing and stuff like that to come to that. And to give you an idea, if we have to work with fiber reinforced planks and poles, I mean, we need to have a specific production line to do so. We have to do a lot of product development. We have to do a lot of testing, etc. I think that it will take at least a year, but probably 2 years before you can go to market with such a product. But if you want to go to such a development, and if you want to support it, we have to start basically today if we want to have it in 2-3 years' time on the market. So thanks for your attention. I hope this was quick enough. Although yesterday I was told 20 minutes, 25 minutes is okay if you want to do that. And of course, I'm the last presenter, so I have a little bit more freedom than Harm had earlier to go on and continue. But there is still some more program to go. So thank you very much.
Thank you, Jaap. Some final questions? Yes, Sofus?
Thank you very much. Have you tested on wind turbine material, and what about the wood that is in the material?
We have not yet tested on wind turbine material, so I wouldn't know. We can take contamination in the what we would do is we would add the fibers after it goes through the mixer melter. So we would really fiber reinforce the material, and I would expect that if the wood is enough fiber, it wouldn't actually be a problem to enter into the product. But we have to look at recyclability of the material after that, because normally our material is perfectly recyclable. But if we have added fibers to it, it depends a little bit on the size of the fibers or of the material inside. I don't know yet whether it also can be just recycled again, and that's for us is an important thing.
It is an important consideration. Yeah. Have you had any thoughts about the quantities of material, the wind turbine blade material that you can use and sell for these products?
If we would set up a factory and we would, for example, make only fiber reinforced material, a factory in Groningen would be able to do around 10 to 15 kilotons per year in plastic and textile material. I think normally you would not go much further than 30% of fibers in there. I think 3,000 tons per year in one facility with a regional function would be a lot.
Yes.
Thanks for the presentation. Do the sample that you're using are totally thermoset plastic that you melt them by pressure and friction?
Yes, it's normally thermoplastic material.
Thermoplastic.
It's thermoplastic material. The process in the green machine in the unwaster is based upon melting. So the material becomes soft. If we put in composite material, for example, that will not melt in the process.
Yeah,
so that's why we add it why we can only actually add it as fibers. But we've not, as I said, we've not tested with wood, but we've not tested with the material at all. We only got a question and we got some ideas.
Yeah, it works for the thermoplastic samples.
Yeah.
Thanks.
We like flexibles and foils and multi-layer packages, etc. Even my runners, they will go straight into the process. That's no problems. They will disappear. If there's a little bit of, if you put clothes in there and there's zippers in there from metal, etc., they will stay outside the process, and just by gravity they will fall out.
Cool.
And every 3 days you have to open up the machine and you have to put out all the zippers and the buttons and what you have. But it's quite. When I first heard about this, I said, I don't believe it. I don't believe it either, but it works quite well.
Thanks. Thank you.
Thank you, Jan.
You're welcome.